Hello everyone and welcome. In this video, I will walk you through a hands-on end-to-end development and deployment process using Snowflake. To ensure a clear demonstration, I will first clear up all my Snowflake environment by deleting any previously created databases. As you can see now, only the system databases remains. For the warehouse design, I have updated the document with my approach. So based on the foundation requirements for cicd pipeline, DBT, engineers, development, and NAELT or ETL processes. Since these are not database objects and are already in place, so I will not creating them here because they are already being created previously. For the most straightforward demonstration of the end-to-end process, we will only be working with two environments, dive and prod. The first step is to set up this environment and creating our databases and their respective schemas. Our schema design follows a layered structure: raw, staging, analytic, and march. Okay, now the dive and prod databases for our platform team has been created, along with their associated and system schema like public and information schema, which is the system views. Next, we need to design the role based on our organization and the structure and the objects within the databases. The best practice for this separation of functional role and access role following the layer design. I have detailed this in the documentation and will not be elaborate on this here. Moving on, we will correct the service owner for our automation process. To simplify this demonstration, I will use the same service user for both CI/CD pipeline as well as the DBT. So this service user will be granted a system admin role. Since this user needs to directly operate in the production environment, it's best to give it the highest level identity for the object's creation. With our environment prepared, we can now enter the core development phase. Let's quickly review the system diagram. Data resides in an Azure Blob Storage account and is automatically ingested into a table in the raw schema of our Snowflake database via snowpipe. We will now create the snowpipe to automate this ingestion. First, we need to use account admin role to create storage integration for both dive and prod environment. Snowflake integrations are a powerful and secure way to establish a trusted relationship between your Snowflake account and the external cloud service like Azure. For this demo, we will assume both environments are using the same storage account. We will also create a notification integration as I mentioned before. Once created, we will use the describe command to get a consent URL. By signing into our Azure account via this URL, it automatically creates the service principal in Azure. We then need to grant the necessary permission to both storage and the notification service principal within the storage account. For I already logged into with my Azure account, so it didn't require me to log in again, and then use this Azure multi-tenant app name. You can see this one is for the storage integration. It's already been created in Azure portal, and we can check from the enterprise application. This one is the storage integration we just created, and this one is the further one for the notification integration I created. It's important to note that since these three integrations are created by the account admin, so their utils must be granted to the sysadmin role. All subsequent databases level objects can then be created by sysadmin. Please also note that when we create the notification integration, we also need to create a queue for an Azure storage account first. Let's back to the Azure portal. So in the storage account, we need to create the queue first. And using this queue, and we go to the event. So create the event based on the queue. And then the notification integration will work automatically. Now let's move on. We need to switch to the sysadmin role first. The sysadmin role is to create the database level objects. And firstly, we need to create two stages. The two stages to link to our Snowflake environment to the two data sources are located in Azure Storage account. So we can refresh the database. We can see there will be two stages already being created. We can already see the files within the stage using list. So in the order stage, we can see there's three files we can verify from our storage account. Let's back to the container and go to this is the Snowflake demo for dev environment, and this is for our prod environment. In dev environment, there's two folders, one for orders, one for customer. So the previous stage for order, there are three CSV files, and for the customer, there's only one CSV file. So now the stages are created successfully. Now let's review the data source file first. So let's go to the data side. This is the CSV file I uploaded to the storage account. We can see for the order CSV file, there is header, and all the files are CSV file. And for the customer file, also include headers. After reviewing the data structure, we will create two tables to store the data will be ingested from CSV file. One is for order, one is for customers. And then we need to create the file format to tell the pipe how to read the data structure, such as indicating it is a CSV file and skip the header row. Now let's refresh the database again. We can see there is the two stage, two tables, and one file format being created. Next, we will create two snowpipe for each data source. To enable the automatically data ingestion, we need to utilize the Azure notification integration we created previously. And for the two pipe, we need to refresh the pipe because the file already in the stage. So for the initial load, we just refresh the pipe and to load the data into the table. As you can see now, after we refresh the customer pipe, there's one file from the stage has been sent to the pipe, and then later the data will be copied into our table. Let's verify if the data has been read into our orders. Yeah, the data from 3 CSV file have been all written into the order table, and then let's verify the table for customer. Yeah, all the customer data also written into the table. Now let's verify if the automation ingestion working fine. So let's back to the storage account and to the dev storage container. Let's upload a file for the order. I will upload. This is the new file. The new order file has been uploaded to the storage account. Let's go back to the Snowflake to see if the data automatically written into the table. You can see this is the new data from the false CSV file. So the data ingestion automatically processed we have tested successfully. Now let me refresh our data sets and take a look at the details of the table. You can see there is the table, the number of the rows, the total row is 8, and the size. There is giving us the details for the table and the definition for the table. We can also open this table details in a new tab. From here, we can see the data DDL definition, the columns, how many 13 columns we have designed for the table, and the data preview. We can also see the sample data from here, quite straightforward. And the copy history, which is the load 3 files. The previous 2 are just for testing. And the lineage is quite powerful. And you can see this is a raw data. The raw table is from the stage. This lineage is a very powerful feature we can revisit later. Due to time constraints, I cannot go through all of dbt powerful features. I will focus on the basic demonstration today. So in our dev environment, the raw layer, we've completed the automatic data extraction from the source. Now let's showcase a powerful data transformation to dbt. Using the raw data, we will use the dbt core to create a view in staging layer and performing the data cleaning, standardization, and the basic data transformations. And in the analytic layer is where we implement business logic and metric calculations. In the mart layer, then contains the business-ready data sets for reporting and analytic, including data model like dim and fact table and cicd2 tables. Now, let's switch to VS Code, which is my local development IDE. As you can see, I already created the dbt project and the models for each layer. Specifically, in the staging layer, we perform the fundamental work of data cleansing and standardization. For example, in the stage order module, we are processing the raw order data by renaming the columns, data type casting, basic data validation, and the cleansing. And for the analytic layer, we do some the business logic transformation and for data analytic. In the mod layer, the models is for the final table, which is for reporting and analytic purpose. Now let's show you how we can use dbt. Let's open the dbt folder first. During the development and debugging phase, we can run the single dbt model. By using dbt run, select the single model name. Let's say we run the stage customer. So it's just a copied model name and paste here, and then let's execute the dbt model. It started to running, which is the dbt version, and a register adapter on Snowflake version. And then it started, the target is dev, so we're running in the dev environment. And this is a module, it's only one step to create successfully. Let's go back to the Snowflake to verify the result. Let's refresh the database. Okay, the view is already being created by the dbt, which is for the staging customer. And by hooking the mouse, we can see there's the 14 record being right into the table. And then we can see also check the details for the table. For the lineage, you can see the staging table is from the raw layer for the raw from the customer. And then we also can check for the previous lineage. It's from the external stage. Okay, let's back to the dbt. Since I already finished all the models done, so I just need to run all the models based on the dev environment. We can run all the models together by run dbt run. We can use the target or any the tag. We can design it. Now let's use the target dev. All the dev models will be executed at one time. In dbt, we will check we found 6 models and 23 tests, 2 sources. So for the 23 tests, I will walk you through how I define the test for some specific columns and the data. And you can see 6 models being executed successfully. We can back to the Snowflake to verify the result by refreshing the database. Okay, a new view in staging has been created and 2 tables in the analytic and 2 tables in mud layer. You can see the definition is create or replace the transit tables. There's 23 columns, and we can also see the sample data with the copy history. There's no copy history because it's using DBT for the data transformation, and the lineage is quite powerful. As I also want to show you. For the marked tables, the previous is from analytic layer, and then this one's the source data from 2 views. And each view is come from the raw table, and then the raw table from the stage layer. As you can see, DBT can complete data transformation and modeling in very short amount of time. It supports code reuse and version control, make it ideally for large team to collaborate seamlessly. Now let me demonstrate the power of DBT's testing capacity. In the schema YAML file, I have simplified to define a few tests for my models and columns, including for column customer ID should be not none and unique, and customer email should be not none, and the status accept value active or inactive. We can run DBT test. Also, I want to test all the models under the dev target. Select target dev. Let's see the result. Target. It will execute the 23 tests based on the different module and different columns. And then the result will be read into a new schema, which is under the which I defined in DBT project under the test results schema. It is executing the testing. So 23 testing is finished. Let's verify it from the Snowflake. Let's refresh the database. Okay, under the dive database, there is one more schema, which is test result. This test result we can use for monitoring and manage the data quality. The DBT process for handling our raw table is now complete. So far, we have finished all the development work in dev environment. Now let's move on to the demonstration of our cicd automation deployment. We are using Azure DevOps, the repo for the version control, and the pipeline for automatic cicd deployment. We will upload our code to the repo and then use the cicd pipeline to automatically deploy it from the dev environment to the prod environment. Now that our local development and testing are complete, let's update our Azure DevOps repository. First, we need to gather all the content we've developed in the dev environment and push it to the repo. This includes the DDL for the 2 tables, the 2 stage, a single file format, and 2 snowpipes. Next, we will commit these changes to Git and publish them to our remote repository. Just to simplify the process, I will not use the feature branch. I will push the code to the main branch directly. Now let's go to the Azure DevOps repository to check the code. We can verify the data has been updated successfully. Now let's use our ADO pipeline to automatically deploy all the objects we develop in the dev environment to the prod environment via our YAML files. Let's head over to Snowflake. In dev databases, we already have all the objects we have developed, including table stage, file format, and 2 pipes in raw schema, and other tables and views in the other layers. Now I'm going to use the schema change via the YAML file to deploy all the objects under the raw schema, and then use another pipeline to deploy the DBT transformation process. Let's do it together. Let's go to the pipeline, and we will create a new pipeline using Azure repository, which is using the existing YAML file. And from the main branch, I will use the YAML file, which is Azure pipeline schema change. Continue. And after check the code, this is all good. Let's run it. Okay, we need to permit to use the environment library and the environment. The library we use to store all the secrets for the Snowflake account information and the password. Let's back to the pipeline. After the deployment finished, we should get all the objects and the raw schema and the prod environment. Yeah, it's all done. So let's verify the result to refresh the databases. Okay, so now under the raw schema, we have 2 tables, 2 stage, file format, and 2 paths. We can verify the result. You can see there is the 8 numbers of rows, and we also can see the details for the table for definition and the data preview. So far, the other layers are empty because we haven't deployed the DBT process. With the schema change, it is generate a new schema, which is called schema change. And then in this table, you can see there's the 2 number of the rows. We can see the data by clicking the data preview. This is describe the files we have deployed previously, which is include 2 tables and stage and the path. When with the metadata information, we can do the tracking. Let's back to the pipeline. Let's deploy the DBT process together. We need to create a new pipeline using our repo and the existing YAML file. And this one will use this pipeline DBT YAML file. This YAML file defines the process how to deploy the DBT in prod environment. That's right. The entire DBT project deployment took about 1 minute, which is a bit long. I will speed up the video by 5 times here. Has been deployed to the production environment. Let's verify the result. Okay, and staging table, we got 2 views, and other layers we got the tables and merge 2 tables. Everything looks fine. Now let's verify if the file can be automatically and successfully read to the table when they are loaded into our Azure Storage prod environment. So currently, our file for customer is 8 number of rows, and for the others, there are 3 rows. Let's go to Azure Storage account to the prod environment. For the customer, we have 1 file. Let's upload another file. Let's go to other folder. There 1 file. Let's also load another file. Okay, all uploaded. And let's back to the Snowflake. Give it some time and we can verify the result. And let's check if the data been read to the table. Wow, it's quite fast. the customer data already right into the table. And the roller also has the second file's data. Alright, thank you for your patience in following along with me. Together we've completed a full demonstration from the initial environment setup and creating SnowPipe and DBT models to use the ADO pipeline to deploy the entire project to production. I hope this demonstration has clearly showed how an end-to-end data pipeline can operate efficiently and with a high degree of automation. I look forward to hear your feedback. Thank you.